Hey everyone. Hey everyone. Thank you for joining. This is the 74th meeting. Today is May 13, Tuesday, 2025. If you are new, welcome. We meet every month. Either myself or someone else would be presenting all kinds of topics. If you would like to present anything, approach me anytime through Discord. I have a link soon, or through Meetup or any like LinkedIn, any other way that you feel like, and let me know what do you want to present, how much time, and I'll be more than happy to accommodate that. I'm actually always looking for presenters and speakers. My name is Kobe. I still have the deciphering object-oriented programming with C++. If you are, sorry, if you are around San Diego and you'd like to either I drop it off somewhere or you come pick it up, or any arrangement that you would like to have. I have like 5 physical books. It's really good one. So it's free that I received from Dorothy. She shipped that to me, and I'm giving this away to anyone. I have a Discord link updated from a few minutes ago. So this is the Discord link. Otherwise, just ping me. I'll get you a link if this is expiring. We're almost 1800, so 1792 members today. Welcome if you're new. Welcome to the meeting. Happy to have you. JetBrains is sponsoring SD San Diego C++ Meetup. Thank you, JetBrains. JetBrains has many. It's a suite of many IDEs. I'm interested in CLion, which is a C++ one. There's other IDEs. I'm also using PyCharm, which is, in my opinion, the best one. They have AI embedded. There is the new Junie that you should have access, I think, to some very early access to Junie, and I think it's part of 25.2 release that should happen anytime soon. No need for CLion licenses. So this used to be a slide that I used to present for the past, I don't know, 1-2 years, and I used to get licenses like coupons that you can use, and I give it away. No need for non-commercial use. CLion is free. So if you have a license, like I had a license and was expiring in a couple weeks, so there is a way through, I think through help or something like that in the menu to convert that to a non-commercial use free license. And this is a huge it's a huge news for the community. So this is great. I really encourage you, and this is free, completely free. And I bet there are some AI tools that you can use on top. Some of them probably free, some of them are with some payment. I'm still reading the C++ memory management book. Almost done with that. It's really great. It's really great book. It's I think one of the, if you're interested in really cutting edge modern C++, memory management, memory whatever, this is the book that you want to take a look, from how shared pointers work to allocators and alignments, and what does malloc versus free versus new versus delete, and all of the flavors and everything that you would like to know about memory management. This is a great book. It's written very, very well. Like, I really enjoy it. And some of the things that we'll show today is inspired by the book. When I was reading that, I thought this is going to be interesting. We start with a couple very fun quiz questions, and then we'll talk about uninitialized. It's a family of functions that are part of the standard library that I don't believe a lot of people familiar with. So this is an opportunity for us to be a bit more efficient and advanced when we write code, especially when we write allocators and similar. We can squeeze more efficiency from C++. So this is a great thing to remember that C++ has in the standard library, and use it when it's a good opportunity, and it's a good use case. Okay, so let's start with do. Okay, so let me stop sharing. We'll start with 98, 298. Let me see. Okay, share. Okay, I really like the Google Meeting interface. Did a very good job. Okay, C++ 23. Everything is C++ 23 in CPP quiz now. Uh, we have a struct, constructor, destructor. Both of them are throwing, and we have a type trait. Is no throw constructible or destructible? Yes, no. Options. The options are we can have uh, either a specific output, compilation error, undefined, dash undefined. What do you think would happen? First of all, this is all with compile time, right? It, is is the constructor a no throw or a throw constructible? Take a look at the constructor. What do you think? Is it a throw or no throw? It's throwing, right? So both have throws. So both of them are throwing, but which one? Okay, so let's take them with constructor. So constructor is throwing. So it's is it a non? Is it no throw? No, because it's a throw. So it's not on the no throw. So let's put n. What about the destructor? This is a bit of an advance. Like in my opinion, this is not 1 out of 3 in terms of difficulties. Just my opinion. I think it may be 2 out of 3 because I think not everyone is familiar with what happens with destructors. So I'll give you a hint. Destructors are implicitly there are some all kinds of, if you have that member or the other member, like members can affect that, but there are no members here, so it's easy. Destructors are no throw, basically no except by default. So they will not throw. So basically, I give you so is it a no throw destructible? Yes. New York. Okay. So you can read through that, but let me explain something. By implicitly, destructors are defined as no except, unless you say that there are except, and like they would throw, and there are some members that turn it into no except false, what we call no except false. But this is not the case here. You cannot hear me. Others can hear me? Yes, no? When people say that they can hear me, and Adnan says yes, and others says yes. Okay, so we good. Dominic, are you good? Talk to me, Dominic. Try to speak.
Yeah, sorry. Yeah, I'm good. There was
Okay.
something accidentally muted the tab, so I don't know what happened, but thank you. Yeah.
Yeah, okay, because it's a nightmare of someone speaking. I don't know how much I'm like
Yeah,
13 minutes, and we cannot hear you.
yeah,
Okay,
yeah.
so let me just repeat myself. Uh, Default implicitly no accept unless there are some members that change it. It's a long story, or you say okay, no accept false. Not in this case. What happens here, by the way, when it is marked implicitly as no accept true, meaning that this throw uh, would not. It's not going to throw. It's gonna eventually gonna do abort. Okay, and I bet there is a explanation here somewhere. Uh, yeah, it doesn't say here, but basically that would abort. So a distar- a throwing this distractor would be is to terminate, which basically abort. So just remember that. This is super important, by the way. Make sure that your distractor never throw. It's a best hygiene management for your application. Just remember that. Just make sure that it's never throwing. It's a whole new discussion about why and how it's useful and all. Okay, let's go to the next one. 334. Okay. Okay, this is easy. It's funny. This is actually, I think this is easy because I don't know. I think it's easy, but it has 2 out of 3, which I think it's the other way around. I think the other one should be 2 out of 3. What do you think happens here? Okay, there's a function that prints something, and there's main that prints something. So both of them are returning int, but both of them do not have the return statement. What's happening here? Dominic, I like your hat. I can't hear you, Dominic. Unmute yourself.
Yeah, thank you. I'm just trying out if this actually works. I hadn't seen this before.
This is nice. I should teach me how you do that. I'll
It's
have
in
my own.
filters, yeah. Well, maybe not you. People are not going to take you that seriously anymore. I think I can do it.
Are you saying people take me seriously? That's good. Okay, so what do you think happens here? Okay, let's start with main. It's okay. Main is fine. Actually, there are some people that said that you should not, like, basically it's return zero implicitly. People said that this is the modern way to write int main and whatever and not returning anything. But if you don't return anything, it's return zero. And people say this is like the modern thing to write main. If I see that, it means that the person is familiar with modern C++ rules or whatever. Meaning the person didn't forget. It's just the person knowingly didn't put any return statement. Well, how about F? It's undefined. This is why maybe because I memorized it, um, I, I thought it's easy. I just like things that I memorized. Supervised is, in my opinion, it's a lot of memory, muscle, memory muscle, whatever. So uh, that's basically one of the things that I just memorized. It's a UB. Uh, this is not hypothetical error, and tidy would catch it. By the way, not sure about compiler warnings or whatever. I can remember, but tidy would find it. This is a real problem that I've seen in production code.
I
So
I'm just wondering what do most compilers do, because I have seen this countless number of times.
uh,
They probably insert something here. I mean, by the standards, maybe
yeah,
undefined behavior, but I could imagine that most compilers are like, okay, let's just give it a warning, but make it just
I can't
make it
remember about
functional.
warnings, but I think I've seen cases where weird things happened. So since it's a UB, you'll see all kinds of things across different compiler vendors and versions.
Yeah, I mean
So
that's generally fair. That's good. That's definitely always good to know if you want to make things portable. Like you'll have to know. Yeah,
yeah, but here's one of the things that I really like in Clang in sorry in C line. It has tidy built in, so and it's working very fast and very well. Like I think this is the number one productivity tool. You don't really and you don't need to enable anything, it's just there. And every release, when I upgrade the release, they'll add more tidy stuff that you can opt in, like more checks. It would give you a bubble. Okay, there's some new checks. So this is a huge productivity gain for you because this is highlighted. And what I usually like to do, like this is why when I write code, the chances that I'll forget something is basically zero, because it would tell me there's like indications on top. Um, and by the way, I couldn't make anything like VS Code out of the box, like make it make it working like fluently like C line. Just like the cross references and all with Clang D in VS Code or Cursor and other forks of VS Code, it works, but I found C line with the tidy and the cross references and all of the refactoring tools are kind of much better. So anyway, use the tools. Then you don't need to remember anything. Okay, so the next thing for us is what I was promising in the beginning, the uninitialized family of functions that I would like to present. So in C++, the whole lifetime, object lifetime is super important. This is something that a lot of people don't pay a lot of attention. This is why we, especially coming from C, where this lifetime of object is not really a thing. Yeah, I see JB saying undefined behavior should be mandatory compiler error warning. Make a CPU more complex than with obvious, non-essential features. Yeah, I agree that I personally would like to see all kinds of UBs flagged. I agree with that. That's my opinion. There's a lot of discussions about should it be compiler diagnosis or no compiler. At least I think some of, for example, if I'm not mistaken, in 26, I think, uh, using an uninitialized is erroneous behavior. So there is diagnosis for that, which used to be an UB. I think this is changed, if I'm not mistaken. So so things are moving to the right direction. It just takes million years until you get it to your like. My team is working on C++ 20. That's new because 5 months ago it was 17, and we are 2025 today. So in 2026, C++ 26 is coming very soon. So we are lagging behind. Yeah, in Rust. Yeah, Rust is doing a lot of correct things in my opinion in terms of defaults, and yeah, I agree. Oh, yeah, I'm not disagreeing here. On like, it's actually on the contrary. I agree that this is an issue. The only thing I can say is that the tools are much better. When I started developing in C++, end of the 90s, tools were non-existent basically with GCC 2.95 and Visual like Visual Studio, whatever it was, MSVC, which was lacking. That's what we had. But today, at least the tools are much better. Okay. Let's start with the uninitialized. So okay, so in C++, as I mentioned, there is object lifetime, and there is a separation between allocation. You allocate storage, and then you construct the object on the storage. If the construction or constructor succeeded, didn't fail, the object is considered to be alive, lifetime starts, and the way we write code and communicate our intent to abstract machine, and it's really important. Like, this is why type panning in some cases is a UB. Speaking of a UB, and sometimes we get away with that because it came from C, and compilers are probably not don't care a lot. Though in some cases it is a pure UB if you have a polymorphic and you do reinterpret cast from one type to an unrelated type, and I've seen that happening. It's crazy. People serializing polymorphic and deserializing on the other, and it's obviously that's not going to work because virtual function pointers and so there's allocation and there is construction. Uh, let's think about a goal that we want to have and obtain memory for multiple objects, like array or containers. We have few options. One option is new, tt is the type, whatever type it is, and then n. For example, I have my object array equal new. Obviously, in modern C++, we don't use new and all, but this is just for illustration. I want to have 100 objects with using the new operator. So what does it do? It allocates enough memory for 100 my objects. It's all aligned and all. And then there is a construction happening for each and every object. It might be no op. There is nothing to like special things to do, but it might, even default constructor might do something. It depends on the members, depends a lot, but there is a construction that would happen for every object. So there is such construction happening, and there's all kinds of rules about what happens if construction fails, and so on and so forth. It's well defined. Issues: what if the default construction is slow, or maybe it does something that I don't really need at the moment? I can defer it to later. Like, why do I need to pay it now? Maybe it's fine to pay it now, but maybe it's better if I can just defer it. So what if I want to construct it later with different values, not with default constructor, something else? We pay with this approach, we pay the construction immediately for all the elements, 100 of them. There's another option, and I'm using here operator new. The way you use operator new in this syntax is basically not constructing the objects. This is basically just like malloc. Okay, so I have stud malloc and stud allocator allocate. That's the allocator allocate is a whole new session about allocators, but there are a few ways, like these three methods, the operator new, malloc, and allocate. Just remember they are similar in what they do. And I have here void pointer raw mem. It's a raw memory. There is not a single living object, just memory for enough objects aligned and so on and so forth. So allocate. So what does it do? Allocate enough memory, no object constructed, just raw bytes. Okay. Benefits. First of all, I'm separating allocation from construction. Sometimes it's good. Sometimes I don't care. I want the construction. It breaks R. You mean R AII or R? What E stands for? Like, I know R AII. What? Oh, RAI. Okay. It breaks R. Okay, we'll talk about RAI. Okay, we'll talk about it. Uh, and you said something, the fact that the uninitialized feature complicated the language. You're talking about you're talking about uninitialized variable. Yeah, yeah. I agree that uninitialized variables are a pain. Um, where where are we? Okay, so okay, but so it's separating allocation from construction. We can control, so we have more control. So C++ is all about giving you control. So sometimes you need that. So how do we? So the challenge is, like, how do we safely create object in the raw memory? We have raw memory. Like, how do we create objects? So first, let's talk about why working with uninitialized memory is a good thing. So as I mentioned, it could be a performance gain, avoiding the upfront cost of default initialization. We don't need that. We only do it when it's needed. More control when and how, especially how objects is constructed. Custom containers are a big clients of this feature. For example, std vector, std string, they allocate sometimes more memory than they needed. Think about capacity versus size. We might have more memory that we need. We're not gonna. So if you think about capacity, let's say we have 100 elements capacity wise, but we only have 10 elements constructed. What happened with the other 90? We're not gonna construct them. This is all raw memory. So when you do reserve space, size is 0. This is a client of this feature of having an uninitialized raw memory. Um, when you do pushback and place back and so on and so forth, it's going to use the uninitialized memory to construct it. Under the hood, if you're familiar with C++ enough, it's all placement new. There is no magic. Placement new is specific syntax of the new operator, where you can tell the new operator, here's a storage, construct an object on this storage. So there is no allocation. You bring your buffer or storage from home. Tell operator new, use this for construction. So that's what happened under the hood. The std uninitialized underscore star functions, it's family of functions. We'll see a few of them. Basically use placement new internally. Okay. Warning or danger. Standard algorithms, they need existing objects to operate. For let's take conceptual copy. And you can extrapolate it to std fill and others. Std move. No, there's two std move, by the way. There's a std move, the cast, and there's std move that actually works on range. Confusing, I know. So conceptual std copy. Here's an assignment on dref dest equal dref first. It requires the destination is a valid object. It cannot be a raw memory. This is not a construction. This is an assignment. And I just repeat myself, standard algorithm, they need existing object to operate on this type of algorithms, assignment. What happened if the author makes a mistake and allocates memory? By the way, this is also true to, I'm allocating memory. I type pan that to some C++ object, and I'm start using it. This is not super kosher. This is basically UB. You cannot do that. You need to start lifetime. And there's improvements coming in C++ 26, maybe in 29, about making things a bit easier on some types of object types, that is, to make things easier for us. But in general, this is not okay. If you try to assign something to some non-existent object, this is a UB. All kinds of stuff can happen, hopefully crash, but not only. Um, Never use the standard algorithm to write into an uninitialized memory. Never. Okay, so always something which already started lifetime. Just remember that when you read code and you see type panning, ask yourself or the author, if you review code, is there any start of lifetime happening here? And if not, like you it requires discussion that you're not stepping on this UB stuff. Uh, so we need algorithms that perform. So if we have raw memory and we want to use standard algorithms, how can I use standard algorithm like standard copy and standard fill and all of the other stuff to use a raw memory? So we need these special algorithms that can take raw memory and they'll do construction for me and they'll make sure that if something fails in the middle of construction, for example, if some of the if one like I have memory and I start constructing data before doing assignment, for example, if it do an uninitialized copy, we'll see that. I want to make sure that this standard algorithm is written well, that things that constructed, if I'm failing in the middle of construction, they would distract in the ideally in the reverse order, by the way. So I want that guaranteed to happen. So let's see what kind of facilities we have in the standard library. Let's just pick up a regular copy standard algorithm. So what is the core difference between stud copy, and I'm introducing new algorithm to you. When I say new, this is the first time I'm presenting that in this slide deck. Uninitialized copy. Why copy is not enough? Why do we need uninitialized copy? Like what is the need for that? Stud copy takes a begin and end, and by the way, we'll talk about ranges as well. There's a couple of slides on ranges. So stud copy takes a range and a destination to copy stuff too, right? Conceptually, this is the assignment. Stud copy overrides existing object. Existing object, it means that the object exists. So they are already constructed. The uninitialized copy use placement new with the copy constructor. So basically what you'll see is something like this. The second bullet on the uninitialized copy. Conceptually, you'll see something like placement new, this ugly syntax. Okay, let's actually take a look at the sides of this expression. There is a new, okay, this operator new, and there is t deref source. So source is basically, think about it, it's just an iterator. So we need to deref it, and then t getting source. So this is a copy construction. Now we have in the middle one. I have address of the deref of the uninitialized destination. So forget about the address of for a second. For a second, the uninitialized destination is the memory that I'm going to write to. Okay, so I'm derefing and then I'm taking the address of. But instead of taking the address of, which is %, I'm using stud. I didn't have stud colon, but think about there's a stud colon address of. So the address of basically is taking the address. And the reason, as you can see in the comment that I put here, because I thought someone would ask, like, why do we need address of? Like, why not? You can have just the ref, just having ref. But the problem is that if someone, God forbid, overloads for this specific class type, overloads the address of operator, and it's doing something crazy, we want to make sure that we actually taking the address off and not the overloads that someone. There's a lot of tricks like that. Think about like the comma operator and all. There's all kinds of tricks to make sure that you don't take the overloads. You take the action. So other stuff is one of the tricks, by the way. Just remember that. Let's memorize this trick. So we need this placement new. Now we have a construction that happens on the raw memory, and everything is good. So vector and other containers might be clients to this API. So in short, copy, assignment, uninitialized copy is constructions, copy constructor, which basically does everything in one shot on the uninitialized memory, which is everything we need. Okay. So remember, I said there is a performance motivation for that. And this is something that if you have some sensitive application that you want to go and fetch this idea and use it, that's fine. Just make sure that this is really needed, but sometimes it is needed. So you're avoiding the wasted work. You have a scenario, you need to copy elements from source to newly allocated buffer, think like std vector resizing. One of the approach is I'm going to construct and then assign, which basically I'm going to allocate the new memory. Default construct, that's one option, default construct, and then loop and calling assign. So first of all, I just default construct, so I'm doing loop, and if I can default construct. By the way, sometimes I don't have a way to default construct. And you'll get there. You'll get how many times do you have std vector and you wanted to default construct and you couldn't because you did that size, not reserve, but that size, and there was no default constructor for this type. Instead, like you get a. Sometimes not every type has default constructor, right? If you implement some constructor and you don't equal default, seconds, to meet someone, in don't equal default of the default constructor, then it's not gonna work. So I'll be with you, JB. Just I'll finish the slide, and then we use to the copy to assign. So basically, this is the conceptual thing. Don't do that if you want performance. You allocate raw memory. You do default constructor if you can, and then you do std copy, destroy and deallocate, and so on and so forth. Sometimes two would be a wasted work. So why do we want to do that? Okay, let me stop here and just take a look at the chat. So it's saying if one doesn't know all relevant details to using an object or a class or an algorithm or a function, then the author of or publishers of the relevant artifacts are, oh, okay. So they didn't have any documentation, which is true. That's not good. If we should make this situation impossible, example Rust, that ran with C++, violates the principle. It's almost impossible to teach CPP these days. So first of all, let's start from the end. It is hard language to teach and to wrap your head around it. I agree. There's tons of stuff to know, and it's only getting harder and harder because the standard, both the core language and the standard library, is getting bigger and more complicated. Just think about how reflection looks like, and I'm just saying, okay, just learning the syntax of reflection would be some learning curve, I would say. So yeah, I'm not even talking about things like executors and other stuff that requires a lot of knowledge, and even coroutines today is not easy sometimes to, like, we had, I think 3 years ago, maybe 3 years ago, yeah, I think 3 years ago I had a coroutine session. It was 2 hours. All coroutine sessions, they need at least 2 hours to scrape the surface. So anyway, it's nothing is perfect. So I agree that documentation is sometimes lacking, and I'm just the messenger. Second approach. The second approach is what we are discussing. So direct copy constructions using uninitialized copy. So you allocate the raw memory, lines, and so on and so forth. Then you do uninitialized copy. You skip the unnecessary default constructions, or maybe you can't even do that. Uh, and then you do copy construction one element at a time. It avoids this whole construct and assign. Uh, there's a good, by the way, Simon Toth. He used to at least once or maybe twice. Oh, he gave Basil in another one, I think, or maybe just Basil, many years ago in one of the C++ meetup. Um, okay, so let's talk about the solution, the stood uninitialized algorithms. They are part of memory. Uh, you can safely construct using this algorithm. You don't need to handwrite the algorithm. You have that. So you safely construct objects into the range of uninitialized but aligned and so on and so forth memory. Usually they use placement new. Uh, this is C++ 17 and 20 uninitialized field. There is also underscore n for number, like you can specify a number of elements to do, just like you have a field and you have a field and field n. Default value. Let's talk about value construct. Value construct using value initialization. Basically, think about primitives, pods, either null pointer or zeros and similar. Uh, the benefit of introducing these kind of functions is it provides a standard safer. I said safer because it does take care of, and there's code examples soon. Exception safe, then the manual placement new loops that you would write. So you don't need to write that. You don't need to write this code. Let the algorithms do that. Okay, here's an example. I have my data with name and value. I have a constructor. I'm using copy and move. So copy the stood string and move. Kind of an idiomatic C++ in the construction. Some cleanup. By the way, this is don't write an empty destructor. This is something that used to have some logging. But if you have an empty destructor, just don't write it. So don't use that as an example for writing an empty destructor. Just don't write it. If you need for some use cases a destructor, just make equal default. So don't write an empty destructor. And then we have a copy constructor, just deleting the rest. Okay. Let's use uninitialized field underscore n to demonstrate the workflow of users. We are clients, we are users of this uninitialized field underscore n. It's basically going to be like field underscore n, but with some additions. So first of all, remember that when I use colon colon operator new, it's like malloc. So I'm getting a raw memory. And I can static cast that. There is no object, just pointer to a raw memory of type my data. And just printing the address. It's not important. Okay. I have an initial value. The initial value that I decided would be, the string would be default 0. So the idea, so there is a stood field, there's stood generator, all kinds of IOTA, there's all kinds of functions in the standard library that allows you to take a range and do something with it. Fill would basically fill this, in this case, 5 elements, because we're using 5 elements as the n, with initial values. So I'm providing uninitialized fill underscore n aligned memory, the number of elements and the initial value, and that's what would happen. So now when I'm printing that, that's what I'm going to get for each and every. And when uninitialized fill underscore n returns, I have an array with valid objects, 5 of them. 5. So if I allocated enough room for 10, but I'm doing only 5, so I have 5 valid elements. The other 5, They are aligned and all, but they are not living object yet. Okay, few things that we need to do. First, destroying the object. So we need to destroy underscore n. So basically, this is someone says, okay, that breaks our AI. So you need to take care of that. And there's multiple. We talked about it last time about GSL finally and all. Like you can slap an RAII on top of that. Okay, so that's one thing. So remember, there is two things we need to do. There is a distractions that need to happen. Hopefully, your distractor doesn't throw. That's one thing. And then there is a delete. So destroy underscore n. So I'm saying, okay, I'm gonna call the distractor one by one for n elements, 5 elements, because I constructed 5. I'm gonna destroy 5, and then operator delete, and just handling all kinds of whatever happens here. In so if something is throwing and I have a valid memory, I want to delete that. Okay, similar to what we had before, uninitialized copy. We have a vector of elements, and I'm just having the size of it, just which is 4. In creating a p destination, and then uninitialized copy. Instead of underscore n in the field, I actually gonna use the 4 elements and construct it on pdest. It's the same idea. I have construction happening on demand on each element instead of constructing a stud vector, like either doing uh, uh, size or whatever. I have a stud string pointer for the destination and allocating enough stud string. It's going to be aligned and all. And same deal, destroy and delete. Take a look at destroy. It's not destroy underscore end. It's destroy of a range. pdest, endest. The endest is provided by the stud uninitialized copy. Provide me one after, just like iterators is open on the right side, right? So everything is all iteration, all iterator concept in C++ holds. If uninitialized succeeded, there are objects that you need to destroy, and you need to destroy them. Yeah, that's for the question. Okay, so let's just take a look at the other flavors. So uninitialized move. Remember, there is a stud move, which that it's not the cast one. It's, I know it's confusing, but there is a stud move and there is a stud move for moving. It's just a different function signature, so it's overload. It's like copy, but it's just going to do stud move to construct it. So it's basically move construction. It's faster if you have efficient, non-throwing, hopefully non-throwing move. The source elements are left in a valid but unspecified test state because we're moving from. Just remember that. It's used when resizing vectors. Make sure that your move constructor is non-throwing one. So the non-throw, and I'll show an example, is kicking in. Default construct I already mentioned, and uninitialized value construct for pods and similar. So guaranteed 0 initialization. So just remember all these standard libraries. Okay. Yes. Someone asked, manual destruction is required! Exclamation mark. You allocate raw memory using operator new. Basically, it's like malloc or stud allocator. I'm not talking about allocator, but by the way, hey, chapter 14 in the book that I mentioned, the C++ memory, if I'm not mistaken, chapter 14, if I'm not mistaken, has memory allocators, which, by the way, it's everything that is all the weirdness of allocators is basically specified very nicely there. So uh, you allocate raw memory, you need to use uh, destroy. There's a problem here. Destructor for my object are not being called when you do operator delete, because the memory allocator doesn't know about the objects leaving. The purpose of the allocator is dealing with storage. Uh, so if you have resources that it needs to manage, so it might be resource leak, it might be all kinds of stuff. So you don't want that. You need to explicitly call the destructor. Destroy, destroy n, and destroy at. Destroy at pointer calls destructor for a single object pointer pointed by pointer. So it's another flavor that I haven't shown. So that's the third one. It's in memory. So that's basically the workflow, the cleanup workflow. Just like someone was asking, you call the uninitialized whatever to do your construction. There is allocation happens before, and then you have a destroy and delete. So that's basically your template. And if you're writing allocator, the template would be incorporated into your allocator. What if I already hinted, so you already know. What if construction failed pathway? If I'm the one that is doing the loop and I have this placement new, what happened if construction throws when I equal 5 and I'm halfway into that? So I need to deal with that. I need to deal with, there is a problem here because I'm doing delete, but what happened with the constructions? The stood uninitialized solution, it provides a strong exception guaranteed. And there is a quote, if the function, which let's say uninitialized copy, fails to meet the post condition, it would hopefully, in reverse order, uh, destruct the allocated, not allocated, constructed object, sorry. So if meaning if the exception throws, the algorithm catch the exception, call the destructor of all object is successfully constructed, usually in reverse order, by the way. So sometimes you'll see implementation that they're not in reverse order in the destruction. Do it in reverse order. It's make things much more natural to the logical thinker of how C++ works in other languages. So the result is the destination buffer is left in a state containing no live objects. So there might be constructed and then destructed or never constructed. Then it's safe to deallocate. So we're almost running out of time, but I have just very few slides. I think I have like maybe 3-4 slides. So that would be a stood vector, capital V. So it's not the standard library, it's something that we came up with. We malloc, we can do uninitialized field. So this would be a vector that takes something to init, like a size and init. So I can do more in terms of capacity, more than n, and then I'll use uninitialized fill to get this range constructed at the time of this construction. Because I'm dealing with the idea behind stood vector and other, which are basically very convenient to use. They do all the heavy lifting of memory management, so you can sleep well, right? You can use stood vector and you know the strong guarantee and all of that, strong exception guarantee. Using the uninitialized field, simplify the exception handling, which is great. Yeah, this is basically my last slide before some summary, a couple of slides of summary just to summarize the things. But ranges are basically giving you the same idea. So let's go over that very quickly. Let's say I have my data. I have A, B, C as strings, and then so I'm constructing vector and creating a allocating row memory. Destination span would be from P dash N. And then I'm calling ranges. Uninitialized copy to the destination from source. I'm using span here to just to iterate. It's convenient. Uh, Destroy and deallocate. So ranges has destroy, right? Uh, I'm using span here, so I can pass span. Span is a pointer in length. Very convenient. And then I'm doing delete on the pointer. The allocator, which is, let's say, malloc or whatever is under the hood, knows what to do with the pointer. Similar concept, just a more convenient syntax with ranges. I really like ranges. Okay, so use uninitialized algorithm when you have raw uninitialized memory. You don't have yet constructed. You want to defer because of performance, because you need to, because you can't really initialize, because you can't use default initialization, the default constructor on the object. There are few reasons to use uninitialized. If you don't need that, you don't need that. You can just have new or use shared pointers, unique pointer, have all of that stuff done for you. That's also fine. If you're dealing with low level and you need a lot of control on memory, you're probably going to use it. Custom containers, memory pools, all of that stuff. You probably want to use that instead of handcrafting your own loops. The key steps is allocate, construct, using, and then destroy and deallocate. So the reversed order. Low level C++ memory management. Take a look at CPP reference for all kinds of examples. C++ core guidelines has resource management, which is under the R section, containers, the C section of. So just Google C++ core guidelines, you'll get the GitHub. Few books that discuss these elements, and I also have resources for you to take a look. All kinds of stuff that I picked up on the web for, like, from books and blog posts and similar. That's it for today. You have any questions? Hopefully this was useful, and this is something that if you need, you can reach out. Take a look at examples. There's examples in the book, in the C++ memory management, some blog posts. I'll post that PDF online so you can take a look at that, and obviously the recording will come up soon. If you don't have any questions, I just would like to thank you for showing up after a long day of coding or something like that. Thanks, and see you next time.
Thank you, Kobe. Very
Thanks.
good.
Thank you, everyone.